So it's a problem you may or may not have considered to this point, but if you're trying to keep a bunch of related data together in your program, you may find it tedious to declare a bunch of variables over and over again. So you could say string phone1, string phone2, and so on, but you may find that really tedious, and you'd be wondering, I wonder if there's a better way to do that. And well, there is, and that would be using an array, as I've demonstrated here. So this lesson is all about arrays. We'll be looking at basic uses of arrays, how arrays work with loops, and using multidimensional arrays and some applications of that. So first we'll look at a basic application of arrays here, and I've created a basic phone book program that stores a series of 5 phone numbers into a 5-element array, and then asks the user which one they want to see. So looking at the relevant pieces bit by bit, our first part is the declaration, which you may notice looks almost like a normal variable declaration, except for the fact that we have this 5 in square brackets. And what this does here is this is telling the compiler that, okay, we're going to create an array called phones that has 5 elements in it. And so the computer will go and do that. And then after that, I set the elements of the array. And so this you would do just like you normally would with any other variable. You have the array reference on the left, and then your assignment operator, and then whatever you're setting it equal to on the right. When you refer to individual elements of an array, is what they're referred to. The individual variables in an array are known as elements. When you refer to specific elements in an array, you give it the name of the array, and then in square brackets the index of the array, or its position there. And it's important to note that the index starts with 0 in C and C++. And so you need to make sure you're not starting your arrays with 1, because then you will find that if you were to say add access, if I can type, a 5th element and tried to build it, if you were to build a program that accessed a 6 element in a 5 number array, the compiler may or may not catch that, but when it tries to access that 6th array element, or index number 5, it will try and access memory that the computer does not have access to, and the OS will shut the program down, giving you a segmentation fault. So you need to be careful when using array indices, because they start with 0 and end at -1 of the size of the array. So after that, we offer the user the choice to see one of the phone numbers I've manually put in the source here. And they enter a number, and here you can see how you can access array elements using a variable. If you have just any old int, and you pass, and within these square brackets, you pass an expression that would evaluate to one of the indices in the array, then it will give you the value of of whatever element is at that index. So say they said they wanted to see phone number 3, it would plug in here and say 3 minus 1 for 2, because remember they start with 0. We told them to go 1 through 5. So it will get number 2, which is the third element in the array, and print that to the screen. So, one of the big things with arrays is that they play nicely with loops. So let's start. Let me set up an example here. So say we have an array of integers called mynums, and we had some iterative variable x, and we wanted to fill mynums with sequentially increasing numbers from 0 to 9. Now, you could do this the brute force way, which is to type out mynums 0, mynums 0 equals 0, mynums 1 equals 1, and so on, but that would take a lot of time. And if you're going, you want to be able to have them all set. with only a few lines of code, and you can do that. In this case, use your friend the for loop, and this is how you set up a for loop in terms of an array. You always give your iterative variable a starting index of 0 because you want to make sure you're starting at the 0 index. And then you say that your iterative variable is less than the size of the array, and strictly less than, not less than or equal to, because that means it will go up to elements to index 10 or elements number 11, and then, as I told you, that will not go so well. And then you increase by 1. And then in that case, for whatever you want to set it to, you just say mynums, and then you pass it your iterative variable, because that is basically keeping track of which index you're looking at. And then you say set to equal to whatever you want it to. And this expression depends on your application, but in this case we're just trying to set through 0 through 9 because those are also the indices. We can just pass it x as well. Same case for displaying arrays. If you want to display all the elements of an array sequentially, you can just use a for loop to do that too. Same setup. X is equal to 0, x is less than 10, x plus plus. And you just say cout mynums x, and this will recurse through the entire array until it has reached the end. And this will work for any operation you want to do in an array, whether it's assigning or displaying or what have you. If you have an array of anything, you can use this for loop method to display the entire contents of the array in just one short period. So I'll save and build this. Not the button. Alright, let's run it. Oh, there it is. See? 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope, there's the 0. So that's how that worked. So putting this all together, a very common application of arrays is to use them as a kind of a map, an XY coordinate map. And the easiest way to do this is to create a multidimensional array, which is you pass it the size of your x. Actually, I would call that y, and I'll explain in a moment. And you pass it your y and your x, and you give them in 2 separate brackets. And this is effectively telling the computer, I want you to create 10 arrays that are 10 elements large. But you can use this as an effective coordinate system. And you can actually add as many dimensions as you want, but there should be a warning. Every single time you add a dimension, you create that power many more elements in your array. So you just want to be careful with memory there, because if you add some 5, 6, however many dimensions to your array, you will start using up memory like nothing else. So generally you won't be going beyond 2 or 3 dimensions, because that's, well, we live, work, and breathe in 3 dimensions. So we'll look at an example using a map here, and we'll look at how to recurse through maps such as this. So let's say we want to just put random characters in this map. And then output and print this map to the screen. So there are two parts to this. First, you need to set the map, and second, you need to display it. So again, you use your for method, but in this case, you actually need to use nested for loops. And if you remember back to the example from Chapter 1, Lesson 3, it's because you have to have a for loop for each. You have to have a for loop for each dimension of your array. I'd recommend starting with your y variable, because it makes it easier to think about in terms of coordinates. Because the way that the screen is set up, you have rows and you have columns, and normally you advance from column to column, not row to row. You have to specifically tell it an end line. So you want to print a whole row first, which is a single y coordinate, before you move on to the next row. So you always want to start out with that y. So remember, C and C++ arrays always start with 0, less than 10, and y++. So in this case, you will want to use brackets with your for loop. And but before you do anything else, because you want to go column by column, character by character on that line, you go straight into the for loop for the next one. So you just go straight into x. X is less than 10, x++. Here, let's have it choose from A, B. Actually, we need rand first. C standard lib. Okay. You can see how to use rand by looking at the tips and tricks page on the tutorials. So, let me just see it first. So, say we want to choose from, we say we want to print capitals A, B, C, and D. So we'll give it a range of 4, case 0, map. I would recommend putting your y index before your x index, just because that's the way the for loops are set up in this case. So that'll make it easier to think about as well. You don't have to, but it's just a suggestion. As long as you're consistent, you will still get the same result. But it helps me think about using multidimensional arrays in XY coordinate plane a lot better. All right. So and then so as the computer runs through this, it'll start the for loop, start y. Y will be on your first y coordinate, and then it'll go immediately into this x thing, go through all of the x coordinates first, then exit x, increase y, and then continue again. Another thing it's important that you should know, especially now that you're going to be looking at XY coordinates in programming, is that more often than not you'll see your coordinate plane work positive x in the right and positive y down, because that's how the screen's set up. Every time you get a new line, you go down. So make sure that your origin is at the upper left as you're thinking about it. For displaying, it's basically the same story. There's just a couple extra things you have to do. So first, you always set up your y loop first, then go straight into your x loop. X is less than 10, x++. All right. And for this part, you just output that index yx. Do not end the line, because if you end the line, that means you're moving to your next y value, which you're not. You end the line outside of the x for loop and at the end of your y for loop, and you can just do that by putting an end line right there at the end. So save it, build it, run it. So there you go. There's a 10 by 10 grid of random A through D characters. So that is arrays. Next lesson is structures.